Okay, this is a video solution for the fifth circuit. Let's begin. We have a 15-volt battery, and there are two branches. One has resistance of 5 ohms. The other has a resistance of 20 ohms. So this branch has two resistors in it, an 8 ohm resistor and a 20 ohm resistor. Because these are in line with each other, the resistances add. So 8 plus 12 is 20 ohms. So we've got one branch with a resistance of 5 ohms, another branch with a resistance of 20 ohms. There are no other resistors in this circuit. So we're asked to analyze the circuit. Okay, start with the current coming out of the battery. So the current coming out of the battery, I battery, is going to equal the total voltage, 15 volts, divided by the equivalent resistance. So I'm just going to write Req. We have to calculate this equivalent resistance. The way we calculate equivalent resistance is we have to add all the ones that are in series together. Okay, I only see one big thing that is in series with the battery, and that's this big piece. So there's just going to be one piece, but that piece is parallel. So when we have parallel, the equivalent resistance is 5 inverse plus the other branch inverse. Now we just talked about how that branch is 20 ohms. So I'll use 20 ohms and then I'll invert that. Okay. So there are two different ways I could go about calculating these. I'm going to do the way that I've written down, 5 to the negative 1 plus 20 to the negative 1, and then I'll raise that to the negative 1, and I get 4 ohms. So this is 4 ohms of resistance. I could have done this another way. I could do 5 to the negative 1 plus, and then I could open parentheses. Now I could type 8 plus 12, that's 20. You can see how they add together in series, so it's just 8 plus 12. And then the whole parentheses would be raised to the negative 1, and then raise that to the negative 1, and that would give me 4 as well. Say that's the equivalent resistance, which tells me that the current coming out of the battery, I battery, would equal 15 volts divided by 4 ohms, and that is 3.75 amps. 15 divided by 4 is 3.75 amps. So I know that there is a current of 3.75 amps. Now that current is going to split. Some of it's going to go over here. Let's use this green. Some of it is going to go this way, and some of it is going to go this way. I don't know how much yet, so we have to move on to thinking about something else. Let's think about loops. Starting at this point. Let's make a loop. And this loop, which is pink, is going to go around like that. Okay, so let's talk about that pink loop. The pink loop encounters a 15 volt up, a gain of 15 volts, and then there's going to be one loss at this resistor, voltage loss, or voltage drop. So I know that the 5 ohm resistor is going to have negative 15. So I will say V1 for the voltage drop across R1 is going to be 15 volts of drop. And because I know V1, I also know R1, which is 5 ohms. I can say I1 equals V1 over R1. 15 volts divided by 5 ohms. 3 amps. The other loop, let's make it a blue loop. Nope, blue won't show up. How about dark blue? Dark blue shows up. So this other loop is going to go through these 2 resistors. So now there are going to be 2 drops. Plus 15, and then there's a drop and another drop. So this, I don't know what these 2 drops are, because there are 2 of them. They probably don't share evenly. But I did just find out that the current I1 was 3 amps. That's 3.75 amps total coming out of the battery, and it splits. And 3 amps goes this way. That tells me that 0.75 amps of current must go the other way. I now know that I2 is 0.75 amps, and the current has no choice. If it goes through R2, it has to also go through R3. So I can say that I3 is also equal to 0.75 amps. Now I know I2 and R2. I can figure out that V2 is equal to I2 R2. That means 0.75 amps times 8 ohms. That is 6 volts. 0.75 times 8. I'm sorry, I misspoke. 6 volts. V3 equals I3R3, 0.75 amps. You know, I know that there's 15 volts total of drop. I've used 6. That's minus 6. So I could just say, well, this is going to be minus 9. Or I could say 0.75 times 12 ohms, 9 volts. Gives me the same answer. Okay, let's check that I have found everything. Did I find the current coming out of the battery? I did. Do I know the voltage of the battery? Yes, 15 volts. Do I know the voltage drop on R1? Yes. Do I know the current going through R1? Yes. Do I know the current going through R2? Yes. The voltage drop across R2? Yes. Do I know the current in R3? Yes. And do I know the voltage drop in R3? Yes. I've analyzed the circuit. Hope this was helpful. Have a good day.